Hello, I'm going to go through every one of the questions from the recent EEDI task. Feel free to skip. I'm going to go in order, so I'm going to do question 1, then 2, then 3, then 4, then 5, then 6, then 7. So you'll probably make a good estimate of how long into the video you need to skip to find the questions you want to find, and watch them and make some good notes, etc, etc. So let's jump in. So this was all on graphical inequalities, which we're going to look at for a couple of lessons because it's a pretty tough topic when we get right into it. First thing you need to do always is find what this line equals, because when you've been drawing it, you've been drawing the line first, either with a dotted or a block line, depending on if it's a strictly greater than means block line, or it could be this as well, and this is a dotted line because this includes it and this doesn't include it. So first we need to see, well, what is this line? This is the line. Well, our x coordinate is always 1. This would be this coordinate here would be 1 0, 1 1, 1 2, 1 3. So this is the coordinate where the line where x equals to 1. However, we're not just going to leave it like that. We're doing an inequality graph. We've got a shaded region. So let's have a think. Well, the x value here is 2. The x value here is 3. The x value here is 4. I've just picked some random coordinates. Well, these ones weren't really on. I could have been a bit better and picked points like this. So if x is equals to 2, x equals to 3, and x equals to 4 all satisfies this, well then we're going to say, well, x is greater than 1 would be our correct answer here. And it would be D. Because values of x are true, and then if we test a value of x, so like x equals to 0, well this doesn't work, and that would be less than. And then we know it's not going to be equal to as well. It doesn't give us that option, but because this is a dotted line. Question 2. These graphs don't scale very well. It's the only problem about the EEDI website. Their images are a bit garbage. So it might be a little bit blurry, but I think we can get the gist of the idea of this. So, which graph describes the inequality? This. Well, first let's see which one looks like the line y equals 2x minus 1. We know because of this, we're going to have a block line. So, y equals 2x minus 1, we know from this here, it's going to cross the y-axis at -1. So, straight away, this one doesn't work, and this one doesn't work, because they cross it at +1, and it crosses it at +1. We want it to cross at -1, so this one and this one work. Next, it needs to have a gradient of 2. So that's a positive gradient. So remember, positive gradient is going to go up like this, and a negative gradient is going to go down the stairs like this. This is obviously a negative gradient. I'm going to put m. M is what we use for gradient. Just saves me writing it out. So by process of elimination, we know this one's going to be true. But let's just go through the full question, because we're not out here just to process of eliminate. We want to be able to do these questions when we don't have a multiple choice in front of us. So gradient is the change in y over the change in x. Let's make a little triangle. Change in x is 1 and the change in y is 2. So 2 over 1. So the gradient of 2. And it's got an intercept of -1. So definitely this is the right line. That is the right line. Let's check it's the right area shaded. And it shouldn't be this area down here. Let's pick this point here. I always think if you can pick 0, 0, pick 0, 0, because it's so easy to substitute into. So substitute it into our y is greater than or equal to 2x minus 1, sub in 0, 0. So 0 is greater than or equal to 2 lots of 0 minus 1. So we're asking the question, is 0 greater than or equal to minus 1? True. So this one definitely works. It follows the line, it's got a block line, and it follows the coordinates work, that they've shaded the right region in, is what I'm trying to say. Question 3. This is the line x equals minus 1. Let's find some points. Well, minus 2, x equals minus 2. This is x equals minus 3 all work. So we're looking for numbers that are smaller than minus 1. So it's going to be x is less than minus 1. And it's a dotted line, so it's going to be this inequality and not that one. So here we're going for B. They're quite easy, them ones, I think. Okay, another one like this. Think about what the coordinates are. Y is always 1. I like to think if it goes through the y-axis, and it's like a horizontal or vertical line, it goes through the y-axis at 1, so this is going to be the line y equals 1. The y coordinate is always 1. Y coordinate 1, 1, 2, 1, 3, 1, 4, 1, minus 1, 1, minus 2, 1 is always a y coordinate of 1. And we've got y equals 2 works, y equals 3 works, y equals 0 doesn't work, and these don't work as well, because they're not shaded in, so they don't satisfy it. So we're looking for values that are larger than 1. So y equals larger than 1. And we know it's not that one because we don't have a block line. So y is greater than 1. We've got A. Question 5. Nice blurry drawing. I'll see how much good I can get it. That'll have to do. Which one represents the region? Y is less than or equal to 2. Well, first let's look to see which one has a graph of y equals 2. Nope, that's x equals 2. Nope, that's x equals 2. It's going to be one of these two. So right now they've satisfied one criteria for me. I'll give them a little tick. This is a y value of 2. We've got a y value down here of minus 2. We've got a y value down here of minus 7. And they satisfy the criteria. 5, 10, and they satisfy the criteria. Well, of their own graph. I'm not saying of the question, of their own graph. Well, let's put this in. Let's substitute y equals 10. 10. So instead of saying y is less than or equal to 2, I'm going to say 10 is less than or equal to 2. Is that true? No, not a chance. Is 5 less than or equal to 2? No, not a chance. Definitely not this graph then. Is minus 2 less than or equal to 2? Yes. And is minus 7 less than or equal to 2? Yes. So we want this graph. This graph is our answer. Question 6 was a pretty difficult one. I think this was the one we struggled on the most, just because it's a hard graph to spot. First of all, we know it's going to go through the y-axis at y equals to minus 2. So I'm going to knock a few off straight away. They all could fit that criteria. So we'll move on to our next bit that we're going to look at. We've got a gradient, I said we can write as m, equals 2/3. This is positive, so we know it's going to be something looking like this. So it's not this one, and it's not this one, because they have negative gradients. They're going down the stairs rather than up the stairs if we looked left or right. A gradient of 2/3, remember when I said all a gradient is when you go one movement to the right, how far up do you go? So in this case, if I go one right, I'm going 2/3 up. Let's see how else we can phrase that. Well, if I go 3 right, I'm timesing it by 3. How far up would I go? If I did 2/3 times 3, that would be 2. So I'm going to go 2 up. So I'm going to look for a graph that looks like this. 3 right and 2 up. So let's start with this one up here. So I'm going to pick this coordinate here. God, it's pretty difficult to look at. This line is way too chunky. 1, 2, 3, and 1, 2. 1, 2, 3, and 1, 2. That looks like it has a gradient of 2/3. I'm going to check that this one doesn't. So if I go 2 up, 1, 2, 3. So these both are the line. These both are the lines y equals 2/3x minus 2. So the thing that's going to be the difference between them is they've just got the opposite regions shaded in. So let's just check this one. We've got a coordinate here of 0, 0. I like to check 0, 0 if it's there because it's so easy to sub in. So I'm going to check, instead of y is less than 2/3x minus 2, I'm going to do y is 0 and x is 0. So is 0 less than 2/3 lots of 0? Remember, this is just 0. I'm going to go into a different colour so it doesn't look all blue. And I'm going to go here. 0 minus 2. Is minus 2 greater than 0? No. That is wrong. So it doesn't seem like this graph is going to work. Let me check this. I've got a coordinate here. I'm going to pick 5, 0. So instead of y is less than to 2/3 x minus 2, well, I'm going to say is 0 less than or equal to 2/3 of 5 minus 2. Don't think I picked a very nice coordinate here because these are not nice numbers, but get your calculator out, do 2/3 times 5, subtract 2, and you will get that. We will get to this stage. Is 4/3 greater than or equal to 0? Yes. So this area is the one we would have shaded in if you were to do this yourself and checked a coordinate to see that works. So our answer to this one is D. There's a lot of work involved with that question because the multiple choice questions I think were really well thought out. So you couldn't just jump to an answer like we could on some other questions. And then our final question. So x plus y is less than 7. They like to do these x plus y ones. There's two ways you can think about this. You can find some coordinates, so you can think, well, when x equals to 0, y must be 7. First we need to think, well, when we're actually plotting the graph, we are doing a little bit of cheating and we're taking that sign out and we're putting an equal sign in. I'm going to do that in a different colour to show that it's not actually the real symbol, but this helps us plot it. So we can say that this would work, wouldn't it? 0 plus 7 is 7. So we've got a coordinate of 0, 7. Let's find some others. Well, we can say when x is 1, y must be 6 because 1 plus 6 is 7. It works up here. So we've got a coordinate pair there. When x is 2, y is 5. And you could go on forever. Let's find which of these graphs has these coordinates in there. So let's look for 0, 7. 0, 7 works. 1, 6. Yep, that's got it. 2, 5, so I'll do it with my mouse so you can see where my mouse is moving. 0, 7, that works. 1, 6 and 2, 5, so this one's in contention. This looks like the line. This also looks like the line. It's the same line as that one. This one here, does this have 0, 7? 0, 7 is up here. That is not on our line, so this one is not the line x plus y equals 7. So definitely that is not going to work for us. And this one has 0, 7. Does it have 1, 5? 1, 6, sorry? 1, 6, 2, 5? No. So that is not the line. This doesn't have the coordinates we figured out that work. We'd be looking for a line more like this that we've seen in the 2 on the left. Okay, so same lines drawn. Just to note, these should be dotted lines, shouldn't they? They should be dotted lines because of our symbol we're using. So for the sake of me not going insane, I'm going to draw over the top of them because of this symbol here, dotted line. Bad question. So let's test some coordinates here. So let's pick 0, 0. Let's see if this is true. So instead of x plus y is less than 7, I'm going to check, is 0 plus 0 less than 7? Is 0 less than 7? Of course it is. So this side seems to be true. This looks like a good shaded graph. But let's just see why this one wouldn't be true. Let's pick this coordinate here, 10, 10. They're saying this is true because they've shaded it in. So instead of x plus y is less than 7, they're saying 10 plus 10 is less than 7. Is 20 less than 7? No, definitely not. So that would be our answer because that is shaded in the correct region. Okay, I'll leave it there, and thank you for sticking till the end if you did.